Today, drinking water takes almost no thought. You turn on a faucet. You pour water into a filter pitcher. You press a button on a purifier. A clear glass of water appears in front of you. And because it is clear, cold, and familiar, your brain immediately files it under safe. Now remove everything that made that moment possible. No pipes, no cartridge, no chlorine, no lab testing, no microscope. No one can tell you whether the water carries bacteria, parasites, waste, or some invisible danger your eyes cannot see. You are standing beside a river thousands of years ago. The sun is going down. Your group has been walking all day. In front of you are three choices: a muddy river, a still pool, and a small spring coming out from under rock. You have to drink from somewhere. So the real question is not simply, did ancient people have water filters? The real question is, before modern science, how did people turn dangerous water into water that gave them a better chance of surviving? The easy answer is that they just drank from rivers, but that answer is too simple. Because clear water is not the same as safe water. A glass can look clean and still carry invisible danger. Ancient people did not solve that with one magic object. They reduced the danger in layers. First, they chose the source. Then they used the earth. Then they let dirt settle. Then they strained and filtered what they could see. Then they used heat and sometimes sun against what they could not see. And finally, they had to protect the water after all that work was done. This was not modern safe drinking water. It was something older and rougher, a chain of barriers. Each barrier solved one problem, and each one made the next step easier. Imagine three sources of water in front of you. The first is a still pool. Insects move across the surface. Animal tracks press into the mud. Dead leaves rot along the edge. The second is a flowing stream, moving over stone, with no obvious smell. The third is a spring, pushing slowly out from beneath rock. If you do not have test strips, microscopes, or a treatment plant, the first thing you can do is not filter the water. It is choose. Ancient people did not need the word bacteria to know that some water was more suspicious than other water. They could watch where it came from, how it moved, how it smelled, what was upstream, whether animals were walking through it, and whether the season had changed it. That judgment was not perfect, but it was the first barrier. And that matters because every later step is limited. If you begin with water full of mud, rotting plants, animal waste, and surface runoff, a cloth or a jar of sand has to do far more work. So the first rule was not to make terrible water perfect. The first rule was to avoid starting with the worst water. That is why springs, wells, upstream water, and moving water mattered so much in many places. They were not automatically safe, but they could reduce certain risks before treatment even began. Which leads to the next problem. What if the better water was not on the surface at all, now cut below the ground? Rain falls onto the surface. Some of it runs away, but some of it sinks through soil, gravel, and rock, moving slowly through spaces underground. Water is no longer just a shining line on the surface. It becomes something stored and moving inside the earth. That is why wells, springs, and underground water systems matter. Modern geology uses words like groundwater and aquifer. Ancient people did not need those words to notice the pattern. Dig in the right place, and water appears. Walk to the base of a hill, and a spring may emerge. In dry regions, people built underground channels to bring water from distant sources to fields and settlements. The Persian Qanat is one of the clearest visual examples. It was not a modern treatment plant, but it shows that ancient societies did not only wait beside rivers, they engineered ways to reach and move groundwater. But this needs a careful warning. Groundwater is not automatically safe. Wells can be contaminated. Springs can be affected by their surroundings. Still, compared with exposed surface water, underground water could add another barrier. Soil and rock can trap some particles, and underground movement can keep water away from some surface waste. In the video, this should become a cutaway. Animals, mud, and settlement on the surface. Water moving below through layers. A well or spring drawing from that hidden path. But once the water comes out of the ground, the problem is not finished. Even better water can still be cloudy. So the next ancient trick was simple. Do nothing and let gravity work. Fill a clay jar with muddy water. At first, it looks like soup. You cannot see the bottom. You cannot tell what is floating inside. Now leave it alone. After a while, the water begins to separate. The heavier grains of sand and mud fall first. A dark layer forms at the bottom. The water above it becomes clearer. You did not need electricity. You did not need a machine. You used gravity. This is sedimentation. Modern water treatment still uses the same basic logic. In treatment plants, coagulation, flocculation, and sedimentation help small particles clump together and settle. Ancient practices varied widely, so we should be careful about saying everyone used the same method. But letting water stand, then pouring off clearer water from the top, is an observable and very drawable step. This section should feel satisfying. The dirty jar slowly changes. Mud sinks. The top layer clears. A hand tilts the jar carefully, trying not to disturb the bottom. But then the narration has to turn. Clearer water is not the same as safe water. Settling mostly deals with what is heavy enough to fall. Fine particles may remain. More importantly, many of the things that make people sick are not visible at all. So settling solved one problem. It prepared water for the next barrier. Now, ancient people could use materials they had around them to strain the water again. Stretch a cloth over the mouth of a pot and pour water through it. The cloth catches leaves, insects, and larger particles. A more complex setup might pass water through layers of sand, gravel, or charcoal. Visually, this is one of the strongest parts of the video. Dirty water enters at the top, each layer catches something, and clearer water drips out at the bottom. It looks like the ancestor of a modern filter. But the script has to stop the viewer from making the wrong leap. A cloth is not a modern filter. Sand, stones, and charcoal are not a guaranteed purifier. What they can do is reduce visible particles, improve clarity, and sometimes improve taste or color. Modern treatment explanations still include materials like sand, gravel, and charcoal as filter media. But trapping particles is not the same as killing every invisible organism. That is the central reversal of this section. The easiest problems to solve were the problems the eye could see: mud, leaves, grit, insects, floating debris. The most dangerous problems were often the ones the eye could not see. So, after water passes through cloth, sand, and charcoal, the cup may look much better. But in the animation, invisible dots should still remain. The water is clearer, but clearer is not necessarily safe. The next barrier has to deal with life too small to see. Now move to the fire. A pot sits over flames, or heated stones are dropped into water. Steam begins to rise. Nearby, another vessel sits under strong sunlight. Ancient medical and technical traditions include descriptions of treating water with heat, sunlight, straining, or other methods. Different places did different things, and we should not pretend one text describes every ancient community. But the records do show that people understood water sometimes needed treatment, not just collection. Modern public health guidance explains why heat matters so much. Enough heat can kill many germs that make people sick. That is why boiling remains an important emergency recommendation today. But this is not magic either. Heat does not remove salt. It does not remove every chemical contaminant. It does not make dirty storage safe. Sun exposure has limits too. Water clarity, container type, time, and weather all matter. So in the story, fire is one of the strongest ancient barriers, but it is not the ending. It attacks a different layer of danger, the living things that cloth cannot see, sand cannot reliably stop, and settling cannot pull to the bottom. The director can show this with a simple contrast. On one side, a clear cup still contains invisible danger marks. On the other side, after heating, some of those marks fade away. Then comes the final problem. Even treated water can become unsafe again. The last step of clean water is not always in the water. Sometimes it is the pot. An open jar sits on the ground. Dust can fall in, insects can land. A hand reaches inside. A scoop touches something dirty and goes back into the vessel. At that point, the water can be contaminated all over again. So water safety is not only about making water clearer, it is also about what holds the water, who touches it, whether it is covered, where it is stored, and how it is poured. Modern household water safety still treats storage as part of the system. The reason is simple. Treated water that is not protected can become risky again. This section should be a split screen. On the left, an open jar collects dust, hands, and insects. On the right, a covered vessel is raised off the ground and water is removed with a cleaner scoop. It looks ordinary, but it reveals the main idea of the whole video. Clean water is not a single moment, it is a chain. Source choice is one link, groundwater is another, settling is another, filtering is another, heat is another, storage is the last link. Break any one of them, and risk comes back.
Now return to the modern filter pitcher from the opening.
At first, it looked like a simple plastic object. You pour water in, you wait, and cleaner water comes out. But now, it looks different. Behind that cartridge is a much older logic. Choose the source. Use the environment. Let heavy particles fall. Trap what you can with material. Attack what you cannot see. Protect the water after treatment. Modern water systems are far more reliable than ancient methods. They use testing, standards, engineering, disinfection, and controlled materials. Ancient people did not have modern safe tap water, but they were already working with the same basic idea. Clean water is not one invention. It is a chain of barriers. You think you are drinking a glass of water, but what you are really drinking is the result of generations of humans learning, painfully and slowly, how not to be harmed by water. So how did ancient people drink cleaner water without modern filters? Not with one secret trick. They avoided the worst sources, used the earth when they could, let dirt fall, strained particles, used heat against invisible danger, and protected the water afterward. The modern filter is more precise, but the problem it solves is ancient. Water can look innocent long before it is safe.